Hello students, in this lecture I'll be discussing about programmable peripheral interface, that is 8255. So 8255 is a general purpose programmable input output device which is used for parallel data transfer. So this 8255, it has 24 input output pins, which can be grouped into three 8-bit parallel ports, like port A, then port B and port C. Port A, port B and port C. So these are 8-bit parallel ports, port A, port B and port C. So all total this 8255 has 24 input output pins. So this 24 input output pins can be grouped into three 8-bit. This group is 8-bit, this group is 8-bit, this group combined is 8-bit. So they function as three 8-bit parallel ports. Now this 8 bits of port C, as you can see here, this 8 bits of port C can be used as individual bits or be grouped into, or it can be grouped into two 4-bit ports. This is upper 4-bit, this is lower 4-bit, so it can be grouped into two 4-bit ports or it can be used as individual bits. So this 8255, it can be programmed into two basic modes, that is bit set or reset mode and input output mode. So what is the function of 8255? We have this 8085 microprocessor. It works as interfacing the peripheral device with this 8085 microprocessor. So it works as programmable peripheral interface for interfacing the peripheral device with this 8085 microprocessor. It has 24 input output pins which are grouped into three 8-bit parallel pits. So this is a 8-bit parallel port, this is a 8-bit parallel port and this is a 8-bit parallel port. Now it has this input output mode is further divided into three modes, that is mode 0, mode 1 and mode 2. I'll be discussing all this in detail. First let's discuss about the block diagram of 8255. So starting with this D0 to D7, as you can see here, this D0 to D7 data bus, these are bidirectional data bus lines. These are connected to the system data bus of 8085 microprocessor. So this data bus are connected to the system data bus of 8085 microprocessor. These are used to transfer data and control word from 8085 to 8255, and or you can say this D0 to D7 can be used to receive data or status word from 8255 to 8085 microprocessor. So this data buses, they are basically connected to the system data bus of 8085 microprocessor and they are used for transferring the data between 8085 and 8255. Now we have this control logic block. So before this control logic block, it accepts control bus signals as well as input from address bus. Which control bus signals? Like RD bar, WR bar, reset, CS bar. This accepts control bus signals as well as inputs. This is A0 and A1 input from address bus, and issues command after it receives the control bus signals and address bus inputs. It issues command to the individual group blocks, that is group A control block and group B control block. Now as you can see that it is having RD bar, WR bar, A0 A1, reset and CS bar. So here RD bar, when this pin is activated, which means CPU, that is 8085 microprocessor, can read the data in the ports or status word through this data bus buffer. Again I am repeating, when this RD bar signal is low or activated, 8085 microprocessor can read the data in the ports. It can, whatever data is there from this 8-bit pins, this 8-bit pins, there is some data from the peripheral device. So microprocessor can read that data through this data bus whenever this RD bar is low, and whenever WR bar pin is low, whenever this WR bar pin is low, the microprocessor can write data on the ports or in the control register through the data bus buffer. So using the data bus buffer, microprocessor can either send or receive data to and from the 8255 depending and the direction of data transfer will depend on the RD bar and WR bar pins. So in this way, microprocessor can send data to the peripheral device through this peripheral interface, or it can read data from the peripheral device through this peripheral interface depending upon RD bar and WR bar pins and using this data bus buffer. Now next is CS bar. Obviously whenever this pin is activated means this 8255 is selected, only then 8085 microprocessor can transfer or receive data through this 8255. So CS bar pin has to be activated to function this 8255. This is chip, this is active low input, and this is a chip enable signal, or you can say chip select signal. Now this reset is used for, this is an active high input that is used to reset 8255. So whenever this reset input is high, the control register is cleared and all the ports are set to the input mode. Now the last pins of this control logic are A0 and A1. So this input signals A0, A1 along with the RD bar and WR bar control the selection of control or status word registers or one of the three ports. So A0 and A1, this A0 and A1 pins, they are generally connected to the A0 A1 pins of the address bus of 8085 microprocessor. So what I am trying to tell you is that this A0 A1 along with RD bar WR bar, it tells us about the selection. For example, if A0 A1 both are 0 means port A is selected. If A0 A1 the status is A1 is 1 and A0 is A1 is 0 and A0 is 1, then port B is selected. And if A1 A0 is status is like A1 is 1 and A0 is 0, then port C is selected. Similarly here also you can see if both are 0 0 means port A is selected. If both are 0, if A1 is 0 and A0 is 1, then port B is selected. If A1 is 1 and A0 is 0, then port C is selected. So this is about the data bus. So this is how, if A1 is 1 and A0 is 0, that is port C is selected. So in this way, depending on the status of A0 and A1 pins, port A, B and C get selected accordingly. Now if RD bar is 0 means microprocessor will read data through this peripheral interface. Microprocessor will read data through this peripheral interface even if RD bar is 0 means data is going to get transferred from 8255 to microprocessor. So how the things will get connected? Microprocessor is going to read port A data. So if RD bar is low means RD bar is activated means WR bar will be 1 because RD bar and WR both cannot be activated at the same time. So if RD bar is low and A0 A1 status is 0 0 means microprocessor is going to read the data of port A, means whatever peripheral devices is connected to the port A, microprocessor is going to read that data. Similarly, if RD bar is low and A0 A1 status is A0 is 1 and A1 is 0, A0 is 1 and A1 is 0, then microprocessor is going to read the data from port B. So whatever peripheral devices is connected here, it is going to read the data from port B. Microprocessor is going to read this data. And if same for port C also. Now if what happens if the status is like A1 is 1, A0 is 0 and RD bar is 1 and W bar is 0. So WR bar is 0 means WR bar is activated, means microprocessor is going to write data. So 101, it means microprocessor is going to write data to the port C. So whatever device is connected with port C, microprocessor is going to write data into that peripheral device, or it is going to output that 8-bit data through this port C to the peripheral device. So this is the function of A0, A1, RD bar, WR bar and CS bar. Now next, talking about this port A, port B and port C. So basically each of the group A, each of the group A and group B control block receives, so each of this each of this group A and group B control block, it receives control words from the CPU and issues appropriate commands to the ports associated with it. So the group A control block controls port A and upper part of port C, that is PC4 to PC7. Similarly, group B control block controls the port B and the lower part of port C, that is PC0 to PC3. So talking about the port A, port B and port C. So this port A, this has 8-bit. This port A has 8-bit latched and buffered output and 8-bit input latch. It can be programmed in 3 modes: mode 0, mode 1 and mode 2. Port B, it has again 8-bit input output pins. It can be programmed in mode 0 and mode 2. Port C, it has 8-bit input output pins. Port C can be separated into 2 parts and each can be used as control signals for port A and port B. In the handshake mode, it can be programmed for bit set or reset operation. So I'll be talking about what is bit set and reset operation and how port C is going to work as control signals in the handshake mode for port A and port B, that I'll be discussing here. So in general, what I'm trying to say is this 8-bit pins, 8-bit input output pins available with each port, they are used to send data to the output device or to receive data from the input device that are connected with these ports. Now talking about the operating modes of 8255, basically 8255 has 2 operating modes: bit set or reset mode and this input output mode. Again I am repeating, it has 2 operating modes, that is bit set reset mode. This is one mode, and the next one is input output mode. Input output mode. So in bit set or reset mode, the individual bits of port C can be set or reset by sending out a single out instruction to the control register. So for bit set or reset mode, what is the control word? Let me show you the control word. Okay, this is the control word. So in this bit set or reset mode, this is the bit set or reset control word format. So depending upon this D1, D2 and D3, since port C is having 8 input output pins, port C is having 8 input output pins. So D1, D2 and D3 will tell you which input output pin of port C is selected. So if D1, D2, D3, if the status of D1, D2, D3 is this, suppose this is the status, D3 is 0, then D2 is 1 and D1 is 1, it means PC3 is selected, means third bit of this port C is selected, and now D0 will tell that whether the third bit of port C has to be set or reset. If it is 1, then PC3 will be set. If it is 0, means PC3 will be reset. And here 0 means The mode is bit set or reset mode. So ultimately bit set or reset mode is basically used for setting or resetting the 8 bits of port C or 8 pins of port C. Now next operating mode is input output mode. So in input output mode we have mode 0, mode 1 and mode 2. Again I am repeating, the next mode is input output mode, and in input output mode we have mode 0, mode 1 and mode 2. So in mode 0, what happens in this mode, port A and port B are used as two simple 8-bit input output ports and port C as two 4-bit ports. So each port can be programmed. We'll continue in the next class. I'm ending this class here.